Okay, good morning everyone. Welcome Sidham, thank you for joining. Good morning. Makar Sankranti. So let's begin with the class. Yes, so today we are going to study about the same topic, continuation part. And this is about the plus subscription. All of you can go for plus subscription. One is a 12-month plan which costs you around 12,375 rupees. There is a 6-month plan which costs you 10,125 rupees. And also there is a 1-month trial price which costs you around 2,250 rupees. This 1-month plan is applicable only for the new subscribers and it is a trial price. So if you want to get 10% off any of these plus subscription plans, you can use this code PRKLIVE and get the benefits of getting 10% off on these subscription plans. Under this, DPPs will be provided to enhance your subject knowledge, full-length mock Unacademy platform. Okay, so this is about the EAMCET Rankers batch. All of you can join the Rankers batch as well. Okay. So in the last class, we have studied about the shielding effect. Shielding effect is also known as screening effect. Now, what is this shielding effect or screening effect? Let me just quickly revise it once. So shielding effect or screening effect is known as the repulsion between the electrons present in the consecutive shells or in the adjacent shells is known as shielding effect or screening effect. So the shells which are near to the nucleus will experience more amount of shielding or screening as compared to that of the electrons present in the faraway shells. The reason being the shells which are present near the nucleus, they will experience more effective nuclear charge from the nucleus, whereas the shells which are away from the nucleus, amount of nuclear force of attraction or effective nuclear charge, and hence the shells which are near to the nucleus will experience more shielding effect. So these are the concepts we had seen in the last class. So welcome Bhagyashri. Thank you for joining. This is a first year related topic. Okay. Let's move on. I don't know, there was some internet issue. So okay. So the representation of how an electron is added to it and how it gains a negative charge. Okay. That's what is being represented here. Okay. Right. Now, depending on the element, the process of adding an electron to the atom can be either endothermic or it can be even exothermic. How it has to be done? Just see. Added to the atom and electron gain enthalpy is negative. Okay. If an electron is added to an atom and the electron gain enthalpy is negative, for example, 17th group elements, that is halogens, by adding up an electron. On the other hand, positive electron gain enthalpies, because the electron has to enter to the next principal quantum level, leading to very completely filled. Okay, so this is a general trend of moving or negative. In general rule, electron gain enthalpy becomes more negative with increase in atomic number across the period, that is from left to right. The effective nuclear charge increases from left to right across a period, and consequently it will be easier to add an electron to a small atom, since the added electron on average would be closer to the positively charged nucleus. We should also expect that electron gain enthalpy to become less negative as we go down a group from top to bottom, because size of the atom is increasing and added electron will be away from the nucleus. Added electron will be away from the nucleus. Okay. So this is electronegativity. Electronegativity already we have studied. So electronegativity is nothing but the ability to pull the electrons of the shared pair towards itself. So fluorine has the most electronegativity in the entire periodic table, and it is also known as the most electronegative element ever in the periodic table. So this diagram generally represents the variation of characters, all those characters which we have studied so far. Yeah. Let us see certain questions. Okay, certain questions based on which this chapter or this topics, whatever we have learned, we can apply this. Okay, so give me a minute. Okay, so moving on to this question, coming to first question, what it state is, find the successive elements of the periodic table with ionization enthalpy. Okay, with ionization enthalpy 2372 kilojoule per mole, 520 kilojoule per mole, 890 kilojoule per mole. Lithium, beryllium, boron elements of the same period. Hydrogen, helium, lithium elements of different groups and different periods. Boron, carbon, nitrogen. This is again different same period, and also helium, lithium, and beryllium. This is also a different group and different period. So here, uh, if you see helium first value is very high value. Okay, high value for your ionization enthalpy. When it is high value for your ionization enthalpy, definitely it would be, if you just consider all these elements, it would be a noble gas, right? I mean, which has a configuration nearly equal to noble gas, and that would be helium. So helium has here 2372 kilojoule per mole. Next would be lithium with least, because this is the first member of second period, so it will be least 520 kilojoule per mole. And then as you move from left to right in a periodic table, size decreases. Therefore, beryllium would be having the ionization enthalpy as 890 kilojoule per mole. Next question. In the modern periodic table, the elements in a period would have same value for what? Would have same value for which number? So definitely when you move from left to right in a periodic table, size decreases. Why? Because the electron is added to the same shell, and shell, which we represented by n, is called as principal quantum number. Therefore, principal quantum number would remain the same. Next one. The correct order of sizes of I plus and I. You know, if I take iodine as the parent ion, then cation will be smaller in size as compared to parent ion, and anion would be greater in size as compared to the parent ion. So option C, if you just observe here, it would be the right answer. For the same value of n, The penetration power of orbital follows the order. For the same value of n, means like 2s, 2p, 3s, 3p, 3d and all. So then which will have the right order of penetration? You know, s orbitals are very near to the nucleus, then p orbitals, then d orbitals, and 5 f orbitals, they are very away from the nucleus. Therefore the order would be s would penetrate more as compared to p, as compared to d and f. Next, which of the reaction will need the maximum amount of energy? So what concept we need to apply here? What concept we need to apply here? Which of the reactions will need maximum amount of energy? That is ionization enthalpy, right? To remove an electron, they have removed an electron from all of them. So here you can just see, in this case where sodium is there, they are removing electron from the neutral atom. So removing electron from neutral atom will not require more amount of energy as compared to when you are removing electron, from an ion, So definitely A option is not there. Then calcium, as you know, it has a tendency to form calcium 2 plus ion. So this would definitely happen very easily because calcium plus 1 is unstable. But if you go to potassium, you know, it can maximum give one electron. From the outermost shell, it has one electron. But the next electron that you would want to remove would be removed from the inner orbital, from the stable configuration. Therefore, you can say when you're converting K plus into K2 plus an electron, it would be requiring more amount of energy. Next question, which of the following statement is incorrect? So, IE1 of oxygen is lower than nitrogen, but IE2 of oxygen is higher than nitrogen. Correct statement. They are asking us the incorrect statement. The enthalpy of nitrogen to gain an electron is almost zero, but of phosphorus is 74.3 kilojoule per mole. Very right answer, because you know, nitrogen, it has a stable configuration, so its tendency to gain electron would be zero. Then isoelectronic ions belong to the same period. Isoelectronic ions belong to the same period. It is not right, because isoelectronic ion can be from any other period also. For example, if I take nitrogen 3 minus and sodium plus, all of them, both of them, they have 10 electrons, but they belong to different groups and different periods, right? This is from, sodium is from third period and nitrogen is from the second period. Then the correct order of electronegativity is, you know, fluorine is the most electronegative, correct? So first and last option you can eliminate, right? Coming to the second one, second and third one. So if you just see, among even chlorine and oxygen, oxygen is more electronegative as compared to that of chlorine, and last would be boron. So option B is the right answer. So always try to eliminate some unwanted answers as well, so that you can just concentrate on the questions that are more of more importance. Okay, two different beakers contain M1OH and M2OH solutions separately. Find the nature of the two solutions if the electronegativity of M1 is equals to 3.4, electronegativity of M2 is 1.2, and that of oxygen is 3.5, and hydrogen is 2.1. Okay, so let us see M1OH. You know, oxygen is greater electronegative. Oxygen is of more electronegative. Uh, M1 is 3.4. Oxygen here 3.5. Hydrogen 2.1. M2OH 1.2, 1.2, then 1.2, then oxygen 3.5, Then hydrogen is also 1.2. So this is more electronegative. This element which is there, it is more electronegative, and this metal which is less electronegative. Correct? So definitely more electronegative means it would be on the right hand side of the periodic table, and on the right hand side of the periodic table they form acidic type of oxides. Okay, acidic types of solution, whereas this is towards the metal side probably, and this would form basic type of compound, and therefore we can say option D is the right one. So based on electronegative value, because as you move from left to right in a periodic table, the electronegativity, it increases, right? So electronegativity also increases and non-metallic character also increases. Non-metals, they generally form acidic oxides, and less value of electronegativity means they are on the left hand side of the periodic table, and hence they are going to form the basic type of oxides. Next one, which among them forms the acidic oxides? So you know metals, they always form basic oxides, always remember, and non-metals, they usually form acidic type of oxides. Okay, now this is a metal. Calcium is also a metal. Sodium is also a metal. Then which will be the answer? Aluminium oxide. Now here it is actually amphoteric in nature. Amphoteric in nature. Not only acidic, but it is amphoteric oxide. This amphoteric oxide means it can both behave as basic oxide as well as it can behave as a acidic oxide, and that's how we chose this aluminium oxide. We should know that it is an amphoteric oxide. Next, last question. Which one will have highest second ionization enthalpy? Which one will have highest second ionization enthalpy? So if you just see, second ionization enthalpy means the energy required to remove the second electron. So if you remove first electron from here, if you remove the first electron from here, it would be 1s2, 2s2, 2p6. Now this is stable configuration, fully fit. If you remove the first electron, minus 1 electron, minus 1 electron. So it would be 1s2, 2s2, 2p3. Okay. This would be 1s2, 2s2, 2p5. That is first ionization enthalpy. Second, we'll see. If you remove from here, it would be 1s2, 2s2, minus 1 electron, first ionization enthalpy. 2p6, 3s1. Coming to second ionization enthalpy. Now, if you observe, so this is half filled. This is neither half filled nor completely filled. This is half filled and this is fully filled. Now, this 3s orbital, it is away from the nucleus, so probably the amount of energy required to remove, even if it is stable, would be little less because it's away from the nucleus. This from here to P5, it is neither half filled nor fully filled. We can remove electron easily from it. Now coming to these two, 2p6 and 2p3. One is fully filled, another one is half filled, and the shell is same. 2p and this is also 2p. But one is fully filled, another one is half filled. Then how to find answer in this case? So fully filled, it will be having more stability as compared to that of half filled, and therefore answer would be here we would require more amount of energy to remove an electron as there is a lot of stability in fully filled orbitals. Okay, so option A is the right one. So my next live YouTube session will be on 17th of this month at 8:30 a.m. and we'll come up with more number of questions, more number of topics, and probably more number of classes, and definitely the question people in your examination. So please join for the next live YouTube sessions, that is on 17th of this particular month at 8:30 a.m. And thank you so much everyone whoever have joined, and please refer to your friends as well to join these classes and understand the concepts in much better manner. Please attend the live YouTube session and also please go for the plus subscription that is there, and use this code PRKLIVE. So thank you so much. Today in the afternoon session, I'll be having one more class at 12 p.m.